Welcome back to Grade 7 Science, Unit number 3, Thermal Energy and Heat Technology. This is lesson number 7.2, Particle Theory, Temperature, and Thermal Energy. In our last class, we looked at how different liquids respond differently when they are warmed or cooled. Why do we get different reactions from different liquids? Well, we shall have to call upon our old friend, the particle theory, to help us out yet again. Remember that all things have different kinds of particles. When we heat up different objects, their particles speed up. The particles in some liquids will move very quickly, while the particles in other liquids won't move quite as fast. In our eyes, we see the different liquids reacting differently. So now we can go by this general rule. The temperature indicates the average speed of particle motion in a substance. So just to give you a quick visual of this, okay, let's first start with a glass of cold water. The particles move slower. That is because water is cold. By contrast, if we look at this kettle here, the particles in the boiling water in the kettle are moving really fast because it's being fed energy. And so that heat, that thermal energy, is making the particles move even faster. A long time ago, scientists were looking for a way to describe the motion of particles in a substance. We can describe the way something moves in terms of its position, speed, and direction of movement, but we cannot see the very small particles that make up matter. What scientists discovered was that they could find out how much the tiny particles can change other things. Energy is a measurement of something's ability to cause changes or to make something else move. We use the term energy every day to describe situations where something causes something else to move or change. So again, just look at this diagram here. We've got several examples of energy. Okay, wind, that movement causes change. Same for solar power. Hydroelectricity comes from the movement of water. We have geothermal energy, which is the focus of this entire unit. Okay, and of course, nuclear energy and biomass. What I want you to do is put the video on pause for a few seconds so you can think of any other examples of energy. All right, I look forward to hearing your responses, but for now, let's continue. Scientists like the term energy because it helps them calculate energy values for many situations. These energy values can be used to help predict what will happen when two objects meet each other. For example, a burning stick of dynamite and a rock. The idea of energy is also used to explain the behavior of hot and cold substances in simple language that we can understand. From the particle theory and the idea of energy, we get the idea of thermal energy. Thermal energy is energy that is used to give power to something and make that thing move. For example, boiling hot water can be used to make a steam engine move. Thermal energy moves from an object at a high temperature to an object at a low temperature. In our next lesson, we will look at how thermal energy can be transferred from one object to another. And folks, this goes back to the 1800s. We'll be talking a lot about trains and radiant history. We won't get into the exact science of it when we talk about trains in history, but just we need to understand this was based all around the principle of using hot water, creating steam in order to power these pretty massive transportation vehicles. Alrighty, let's wrap up today's video and set ourselves up for future lessons by considering the following. Where do we see examples of thermal energy in everyday life? Okay, thinking back to the earlier diagram of the kettle of boiling water, that's an example of thermal energy. But what I want you to do when I'm speaking is put the video on pause and think of items or appliances you see in your home and at school that would use thermal or heat energy. If you don't feel ready to take on this challenge, it means you to go back and watch this video at least one more time. And then when you're ready, please put the video on pause. All right, I look forward to a great discussion of this lesson, hearing your answers to the questions included in this presentation. But until we meet again, this concludes today's video.